welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Hi everyone, welcome to the House of ZK Radio, a focused podcast and media channel exploring everything zero knowledge, from its fundamental principles to the latest advancements in the industry. I'm Alice, education lead at ZKM. Today I'm joined here with our guest Yumin, who is CTO of Galxe. Thank you so much for being here. We're really excited to have you.
Thank you, Alex. Hi everyone, my name is Yumin. I'm the CTO of Galxe.
Yeah, thank you so much for being here. Curious, Yumin, if you could first start off with like an introduction to yourself. So how you got involved in first like the Web3 space and then also got involved into ZK.
Yeah, sure. So I actually started my journey of Web3 in 2017, where me and the co-founders of Galxe, Charles and Harry, were built a live streaming platform called DLive. It was for esports and live streaming esports. Similar like Twitch, but it's basically the crypto version of Twitch that we were trying to realize I would say a fantasy that we can build a live stream platform that is for the community, by the community, using kind of like unique economic system that we only take 10% cut for all the payment and subscription for users. And then I think it's in 2022 I joined Galxe, where Galxe, I think it's probably known by many like players in the industry that it's a questing platform. So at Galxe, what we do is basically for Web3 projects, you can create quests and campaigns to onboard your users, right? For example, to follow ZK House on Twitter, you get a credential, then you host that campaign, you get NFT rewards for following. Users basically use Galxe to explore Web3 projects. And a major part of the job of Galxe's backend and smart contract is basically to verify that what this user has done, is he qualified for this reward. And this naturally leads us to exploring the ultimate solution of ZK. Basically, we hope that we can use ZK to protect users' privacy and building so-called self-sovereign identity services for users that they will be able to generate a proof using ZK in their local devices, and then we'll basically only check the zero-knowledge proof without knowing anything about the user. So that's what get me into look into all these ZK solutions and see what we can use ZK for our purpose.
Yeah, that's great. I think it's really great that you always had that community and user focus. So you first, as you mentioned, started off with that live streaming and esports platform and then moved on to Galxe, but then really wanted to optimize for building that self-sovereign identity for users. So I think that's really great. So just on the topic of ZK, what are some of the main challenges that you see surrounding its adoption, and why it hasn't really become too mainstream as of yet? What are some barriers and challenges that you see in just adopting ZK?
I actually think there's not much challenge left starting from like this year. But I think it depends actually. For Galxe, especially for Galxe Identity Protocol, the challenging is proof generation. The proof generation, especially the proof generation cost in user's device. So because our approach requires every proof to be generated on user's device and specifically user's browser, because having user to install another app is a huge friction. That basically makes you lose 90% of users. So all our solution was built around enabling user to collect all their credentials in their browser and generate their knowledge proof from there. It needs to be very, very fast, that user will basically feel that it shouldn't feel that a zero knowledge proof is being generated. It's just like you click a button and something was done. like you are interacting with a centralized app. So that was a major challenge, and if we were looking at the market, the solution was not that much. Circon was a beautiful implementation, so that's why we chose it before. But it has been there for like many years. Initially built by Iden's team, right? Funny thing is that we even found a minor bug in Snark.js, one of the most popular driver for Circon, and that's for us. But for other applications, for example, like ZK Rollup, where they are using zero knowledge proof mostly for compression, the compression of computation and data. Privacy is not an issue, so they can even run this proof generation in public. Any supercomputer, any super server has many GPUs. I think for them it's the cost versus the finality they got from the zero knowledge proof, right? I know that because we also work with SP1, the Succinct, they provide prover market that has bring down the price a little bit and also the barrier. So that's why we're saying that I think a lot of these barriers will be gone this year. But for some use cases like us, if you wanted proof generation in browser, it's still a little bit challenging.
And it's pretty amazing how we've reached the point where we can just generate a proof from the browser and on any kinds of user devices. And you mentioned about kind of simplifying that user experience where they're just able to click a button and generate that proof rather than having the users say, write the circuits directly or go through like a very lengthy onboarding process in order to generate these proofs. So pretty incredible that we've reached this stage now. And like what you mentioned, like many of these barriers, like with cost, with the time for proof generation, you mentioned we can see those be alleviated within the next year. But I'm also curious to hear, how do you see this space evolving over time? Do you have any kinds of like predictions for what we can maybe expect in the next couple of years? So any sorts of new opportunities, new challenges that may come up, or as you say, the lessening of some of our current challenges that we see today?
Yeah. So although I mentioned that right now it's possible for us to generate proof in browser, but if you look at Galaxy today, it's still not that popular. We opened this feature to some of our core privacy related applications like Galaxy Passport, where you have all your passport information stored in a ZK friendly format and you can generate arbitrary zero knowledge proof against it. But for example, our Twitter credential and Discord credential, for example, these are still not like fully ZK'd. Users are still using our centralized solutions just because of the performance issue. So we're still like, it's working like but it's working for critical jobs, but not like so it's not easily working for everything. So that's the challenging on our side. For ZK rollup and all the other like ZK solutions, I think it's as long as there is an application that can justify the cost of generating a proof, because verification is basically like cheap. So I believe there will be a lot of applications coming up, become like ZK native. And in the long term, I hope that every application should be built with ZK by default.
And we're definitely making a lot of strides towards that future vision. So it's very, very exciting to see that. I also wanted to speak a bit more or discuss with you more about gravity specifically. So curious to hear what the intention was behind Galaxy developing its own EVM layer 1 and why this decision was made and was more advantageous than, say, adopting like an existing L2 solution in the market. Were there any kinds of trade-offs, any kinds of other major like decision-making factors you had to consider when doing this?
Yeah, so the debate at that time was basically how how fast you want your change finality to be. Meaning that, like when we say finality, it basically means that when a transaction is processed, how long do you have to wait to trust that this thing can never be reverted? It becomes immutable. We'll look at all these layer 2 solutions. They are good. If you want to build something application specific, I believe layer 2 is the solution. In general, like for example, if we just want to move every functionality of Galaxy onto a blockchain, we'll just use a layer 2 because we'll be playing with ourselves. Every state transaction can be verified either through optimistic protocols waiting 7 days or zero-knowledge proofs. Right? That's great. And generally, like for optimistic protocols, you wait a challenging period. Sometimes you configure to be 5 days, sometimes 7 days. It's up to actually up to the owner of the layer 2. And for ZK rollup, you're basically waiting the time for proof generation. And you don't want it to be, it cannot be that fast. It can be like 1 second, 2 seconds, sometimes take minutes, sometimes take half an hour. But it's generally much better than optimistic rollups, but also comes with a cost, right? So we look at this and thinking about why we are building a layer 1. That's because we want to build a so-called omni-chain app. Galaxy has integrated so many blockchains. I think right now the number is 50 or 40. That's huge. And we see having a huge, user experience issue interacting with all these different blockchains. They basically have to bridging their assets from different blockchains to pay gas fee, and not to mention if there's a new opportunity on Solana, they want to build some tokens there, bridge some tokens there, some asset there, USDC to buy meme coin, or they basically see there's a new vault, DeFi vault on, for example, Base. They will direct their token there. It's so fragmented. So we want to build an omni-chain solution that basically become the settlement layer for all these chains for users. That user basically lock some states or bringing their stuff to our blockchain, and our blockchain becomes a hub for user to interacting with all the other chains. So if you want to be this kind of hub, finality is very, very important because every message passing through one blockchain through your hub to the other blockchain requires you to have very fast finality. If your finality is 7 days, that means that theoretically it takes 7 days for one message to be finally reaching the other blockchain. So that's unacceptable for us. So that's why we are building our layer 1. We believe that running a consensus algorithm is the good solution for faster finality.
Got it. And really focusing on that, providing that kind of user experience where they're able to have this cross-chain interoperability between different chains,
Yep.
which, as you mentioned, requires fast finality. Okay, sounds great. Yep. And also wanted to talk a little bit more about some design considerations that you guys made for the architecture behind Gravity. So, for example, I know you guys have built the Gravity SDK on Aptos, and then you use the Aptos BFT for consensus, and then also integrated with some other staking protocols with for example, Eigenlayer and Babylon. Very curious to hear about the motivations and the approach that went behind this kind of decision making for incorporating these kinds of design considerations.
Mm-hmm. Yeah, so I think there are 3 sub questions here. So the first one is why we build Gravity SDK on Aptos. Well, short answer is they are the hidden gem of the Web3 community. If you look at all these metrics, Aptos actually have the highest record of TPS being stably running on mainnet. I can remember the exactly date, but it was last summer. I remember there was an app called Crypto, some kind of Crypto Kitty stuff that tap to earn, and they were reached, I remember it was 8,000 or something TPS stably for a couple minutes, and the whole day they process probably a billion or something transactions without having any like service degradation. And that's the engineering side. And for the consensus algorithm, so Aptos BFT is the SOTA of PBFT algorithms. So I know people will mention like other so-called parallel consensus algorithms. They think it's better, but for applications like DeFi and even meme coin traded part of DeFi, I would say, Aptos BFT generally just work best. If you want to know more detail, I would suggest people to follow Alexander from Aptos teams on Twitter. He's very he shares a very interesting ideas comparing all these consensus algorithms, and he's the author behind them. And I remember there was the one more question was about restaking. Yes. So if you look at remember when I built a layer one, so the trust is a big issue. Like having our own token staking and hire some random people to be our validator is not the ideal world for us. If you look at like Ethereum has, I think it's almost 1 million validators, and all these restaking tokens is a couple billion, and not to mention like Bitcoin's theoretically has like more than 1 trillion stakes, and all these stakes with restaking protocols can be used to secure our blockchain. And so ideally, even if let's say like Galaxy or Gravity, the organization, the dev community will just suddenly gone, this blockchain, if it's powered by restaking protocols, it can last forever, as long as people are willing to join this blockchain using their like tokens, like for example ETH and Bitcoin, to secure it. And if you are building a blockchain that can only be secured by your own token, that's not ideal. If your project, like for example, like for bootstrapping is an issue. Like initially you have to hold a lot of these altcoins, and later stage, it will basically like the altcoin's price when it fluctuates, it will affect your network security. Neither of these is ideal for us. So that's why we see that bringing restaking, bringing the asset and the stake security properties from Ether and Bitcoin is a necessary step for us.
Got it. Yeah, it's always very great to hear the reasoning behind these types of decisions that were made into the design. So thank you for that. And I wanted to go into some more detail about the Gravity SDK itself and its pipeline. I'm wondering if you could shed some light onto the different stages that are within the SDK. And I know that you guys incorporated a 5-stage architecture. So also wanted to hear about the intentions behind that design as well.
Yeah. So the reason why we brought in pipelining is for higher throughput and faster finality, latency in this case. Like because finality is decided by consensus algorithm, and then the lower latency we have, the lower theoretically finality we can reach. So pipelining basically making a blockchain that can doing multiple things at one time, and the latency for producing a block will initially was like every stages combined together, the time that needed, becomes basically the largest time consuming component of the pipeline. We have we call this a 5-stage pipeline. So the first stage is we call transaction dissemination, where users sending transactions to mempool, and we run quorum store to basically batching all these transactions into bigger chunks, and that's the first stage. And then second stage is we run Aptos BFT. In the consensus algorithm, we order all these transactions, and then it's passed through the third stage. It's the execution, which our parallel EV and Gradient, we're basically executing them in parallel and producing the new states for the next block. And then the new states will be passed to our state commitment component, the stage that it calculates the state commitment, which for our case is the Merkle root, the MPT root of the EVM block, and then this state will be passed. And also in this stage we will run we call it like micro consensus, making sure that all validators agreed upon this state, and then finally will be passed through sent to the storage layer that will persist all these changes.
Got it. So the process, as you mentioned, starts with the transaction dissemination and then running the Aptos BFT, the execution with your guys' parallel EVM, and then the state commitments, and as well as sending it back to storage.
Yes.
Okay, got it. And also very curious to hear about specifically some of the optimizations that you guys made on Reth, and how you guys were able to produce this to gravity-based Reth. So what kinds of challenges did Galxe come across when during that integration process with the EVM execution layer onto the Gravity SDK? And then from there, what kinds of like optimizations were made, like for example, specifically on Gravity Reth to address these kinds of challenges or limitations that you came across?
Yeah, first of all, Reth is beautiful. It's highly optimized. It actually eliminates a lot of like our initial planted optimization, because when we read Rest code, we found out, oh, it's already done. That's beautiful. But the bigger challenge for us is that Rest was built for sequential execution. In what the major problem is that it's not pipelined. Remember, there are 3 stages actually running within Rest: the execution, the state commitment, and the storage. These 3 are right now has to be executed sequentially in Rest, because that's how Ethereum works. We basically kind of like build another driver, we use a term called BSR, block string reactor, that makes Rest a reactor of the blocks streamed from consensus. So that's how we make Rest pipelined. And there are also some minor issues. For example, we realized that when we were benchmarking it, we realized that the state provider, which is an abstraction for the execution to do state access, for example, to read users' data, was not parallelizable, because there was a read log per each read. So that's something like, it's a technical detail, but it's also something that we are trying to solve.
Mm-hmm. So some of the main optimizations that were made were making Reth more pipelined with BSR, and then also adjusting that parallelization as well.
Yes.
Okay. Yeah, sounds good. And also going into some more details about the Gravity's parallel EVM, which you mentioned when we were discussing about the 5-stage pipeline and the SDK. Wanted to hear some more about what role does developing the Gravity EVM contribute to the Gravity chain in general, and also know that you guys have adopted Aptos's block STM model to it as well, and wanted to hear some more about the intentions behind doing so and what further advancements you guys made on top of that model.
Mm-hmm. Yeah, so let me answer the part with block STM first. So block STM is actually still the soda. I actually heard a lot of people, when we're saying that we're building our own parallel EVM, they told me that, just use block STM. It's a solved problem. People consider it as a solved problem just because block STM's performance is so good. And it's kind of true. We're actually experimenting it. So our improvement was part of like the future work listing block STM paper, that to introduce transaction dependency, optimistic or pessimistic, into the execution, into the block STM parallel scheduling. We do see, so our goal is basically that, have like the higher CPU utilization under some cases for block STM. But, well, in general, in our benchmark, I'll be very frank, in many cases, including the real world examples, block STM is performing very good. And I believe that it is enough for most blockchains. Doesn't matter if you're layer 1 or layer 2. And going back to the question why we're building our own parallel EVM. So one reason mentioned before, we want to optimize it. We want to higher CPU utilization for block STM, in specifically reducing the number of re-executions brought by transaction conflicts. What we're gonna use this CPU for? We hope to give user lower gas fees, especially actually for ZK applications. So a lot of like if you like Ethereum, a lot of like cryptographic primitives are charged a lot. You wanna verify now a Group 16 ZK proof on Ethereum. It's well actually including call data, it's at least 300k gas. I know the sort of limit is 20 to 220k, but it's actually a lot more. And then it becomes very expensive. It becomes a huge barrier for users and applications to consider ZK as part of their solution. If we can bring down this, when we have parallel EVM, CPUs in our imagination will be much like free. Think about all these validators, they're already running there. When their CPU are idle, we should actually charge user for zero for computations. And to do that, like if everything is sequential, you cannot really do that when it's zero. Basically, your blockchain got congested immediately. But when it's parallel, and all these parallel executed CPU cores are basically doing free job for all these transactions. So that's one of the reasons why we think that we need a parallel execution with very high CPU utilizations to give user lower gas fees.
Mm-hmm. And I really liked how you mapped out the kind of thinking behind that approach for adopting the parallel utilization, and then also trying to optimize for that CPU utilization as well. And overall, as you mentioned, like reducing the number of re-executions from, say, transaction conflicts, and then overall lowering those gas fees. So really liked how you mapped that out. And I wanted to scope out a little bit and discuss with you some of the optimizations or some of the approaches you made with the overall user experience. So how does Gravity enhance the, say, developer experience, and how does this user experience compare to, say, some other L1s that we see in the market?
Mm-hmm. Yeah. So first, Gravity is no different from any other, like I would say, EVM L1 in the future. It's basically, hopefully, it's just faster in terms of throughput and latency. But for developer experience and user experience, it's the blockchain doesn't really support it directly in its functions. There are some like features that we will see that will be very unique in Gravity. For example, we'll have very cheap zero-knowledge proof verification. We will provide a lot of like cryptographic primitives. But for the developer and user experience, our plan is to build a developer community. We have a team that's building, we call it Gravity Toolkit, that it allows user to easily build omni-chain apps. For example, to access states of other blockchains, with almost like down to minimal cost. Hopefully, can be like zero cost. And we will build SDKs for users to transfer their assets and bridging messages from different chains to Gravity. And also like Gravity itself being very like low latency and higher throughput, there can be many interesting applications that I know other high performance layer 2s or layer 1s are also chasing. For example, having just order books on blockchain instead of like the current dominating AMM style decks.
Yeah, I see. So, yeah, you guys are providing, at least contributing to the developer experience side, like toolkits so that developers, users can easily build these kinds of omni-chain apps. And then while the costs are lower, and then also SDKs for users to bridge between these different kinds of chains. And yep, you also mentioned that like you in the future, perhaps now you're also incorporating some, you intend to provide some other kinds of cryptographic primitives to Gravity as well. Um, can you shed some light into uh, perhaps some like examples of the types of primitives that
Mm-hmm.
you guys are intending to incorporate and what that may enable for users? Any types of use cases that may come out of it?
Yeah. So, for example, passkey authentication. Right now, it's like 1 million or 2 million gas, depending on your solution on Ether, on EVMs. It's just because we don't have the curve um, on EVM. Then it's actually a very easy introduction, easy part for us to basically introducing more curves onto our blockchain so that many other proof systems that rely on those curves can be easily verified. Within less thousands of gas, maybe even less with parallel execution. So with this, I know people talking about like the account abstraction wallet a lot. Imagine like you can basically with like the SCCP 256 R1 curve on our blockchain. You can easily verify your identity using the passkey stored on your browser or phones. Then a wallet probably would become a much better user experience for remembering your private key.
Yeah, got it. And I also wanted to uh, transition into speaking more about Galaxy's identity protocol, which is another type of infrastructure that you guys are working on. And going back in the beginning, we talked a little bit about building that kind of self-sovereign identities. Um, I'm wondering what challenges do you see currently exist with existing um, self-sovereign identity solutions and say with verifiable credentials as well, like in terms of scalability, in terms of security concerns, in terms of privacy concerns. What challenges do you see with current solutions today?
Mm-hmm. So technically, I don't really see any technical roadblocks ahead. I do mention the proof generation performance might be an issue for users. Like if you have so many credentials and you want to generate a proof using all of them in your browser, it will take some time. It will jeopardize your user experience. But I don't see really like use cases, at least from Galaxy, that needs you to like input hundreds of thousands of credentials. Usually, it's just that you will use like 10 or 20 credentials, and that can be generated. And for this number, a proof can be generated within seconds, so it's no big deal. But I do see the gap is sometimes I think it's an ideology problem that people are still living in a Web 2 world that we are so used to lose our privacy. We're sharing our information with everyone, with all these applications. When they prompt us the OAuth, we just say yes. Know my email, know my image, I don't care. Just give me an access to your app. People are just accept to the norm right now. And also like when you file your credit card application or well some other, for example like the mortgage application, you basically give out everything about you in that application. And I was actually very surprised to find out that your home address and a lot of your information is public on the internet because of US like the credit system and the housing system and that. So I think that ZK and identity protocol should play a bigger role to like improve all this area. But right now it is not happening just because we haven't reached a point that everybody realized that we need to protect our privacy. I would believe at some point, maybe it's due to some social event or something get really popularized and it's ZK by default, people will accept that. Well, even an application is not ZK, it cannot protect my privacy. I'm not gonna use it. But we're still on the road. That's what I think the major like the roadblock for adoption of self-serve identity.
And it's really great you mentioned that because yeah, there are quite a few people like in the space. Like I know in my life when I explain about like the importance of privacy, a lot of people say, well, I don't really mind about like giving my information away to say like these services that I need. I don't really mind when that happens, but um, yeah, it's really great you brought up the point that we're kind of all conformed to these norms of sharing our information in exchange for a service or for some kind of application, and that should be changed in the future.
Yeah.
And hopefully, as you say, we can see more and more applications become ZK by default. And on that regard, I know that you guys also incorporate on the ZK side proof aggregation, um, specifically for verification. So, wanted to hear more about some of the advantages that you see with incorporating this kind of proof aggregation, like in terms of, say, the cost for generation, maybe the speed for how fast these proofs are being generated. What are some of the advantages, and are there any potential limitations or drawbacks for this approach as well?
Yeah. So, um, specifically, we have already integrated Libra in our SDK. That if user want to verify their proof on mainnet, Ethereum mainnet, instead of like taking a taxi that pay 300K gas, you can join a bus of Libra that maybe you only need to pay a couple thousands of like verification cost. So the major benefits today for proof aggregation is still cost saving. It sacrifices basically it's a the bus versus the taxi model. That if everyone like we use very fancy hardcore proof aggregation circuit to basically compress all your proof into one, and then we can all share this one verification cost on chain. That's a major reason we use proof aggregation today. And as I mentioned, like hopefully in Gravity, when we bring down the cost of proof verification, we don't really need aggregation that much. But because there's a trade-off, right? When you're taking a bus, you wait in the bus stop. When there's enough people, you guys get on the bus. When there's not enough people, well, you just have to take a taxi in the end, or you pay the whole bus. So that's a trade-off, and we hope that when their not proof become much cheaper, proof aggregation will not be a necessary step for most of these applications. But still, I believe it will be requisite for some applications that requires a very high volume of proof verification on chain.
Yep, and I really liked the bus versus taxi analogy that you used to describe the trade-offs there. But yeah, as you said, hopefully, um, when proof generation becomes cheaper in the future, um, we won't need to use proof aggregation for a lot of our applications anymore, but instead just for those ones that are like either very highly intensive or, as you say, require a high volume of number of proofs that need to be generated at once. And wanted to also ask you um, about the general approach that the Galaxy Identity Protocol takes in um, in like for example for users who have different credentials within multiple platforms. It all comes back to the same user, but what kind of approach does Galaxy take for all these users to be able to connect all of those identities from different platforms while preserving privacy, while incorporating that ZK component?
Yeah. So we prioritize privacy for this solution. So I know like there was there are some other applications. Basically, they have their own some kind of identity system that you connect your identity from different platforms or to this identity of our platform and generate their knowledge proof on that. So we see a privacy leaking issue here that this platform as the proof generator, aggregator will actually know all the linkage between all your social accounts and EVM addresses. Our approach is purely cryptographic. So in general, user talk to different platforms and providing them a pseudonymous identity. And behind this different pseudonymous identity, there's one secret that generates all of them. As long as the user knows this secret, he is the actual owner of all these credentials of different platforms. So then he will be able to generate a zero knowledge proof that combining all this. So that's our approach. So basically, you can imagine as user has a private key, a secret, and with this secret, he can having credentials owned by different identities for each different platform, so that even if all these platforms they collude, they work together, or some hacker got all this data or government got all this data, they cannot really link this user into one. Only the user himself he can.
Only the user himself is able to link all of those identities, connecting it back to the origin, which is himself.
Yes.
Okay, got it. And I also wanted to ask you a bit more about some use cases as well with the identity protocol. What kinds of use cases can you see be enabled with the with Galxe that aren't really possible with some other some other self-sovereign identity solutions, some other verifiable credential solutions? Are there any that you're particularly looking forward to see being implemented?
So for Galxe, one we consider this as a crown jewel is fully on-chain questing. So right now, why we have to do this in our backend is because, for example, I want to Alex to participate in some kind of questing that allows you, requires you to follow, for example, Galxe's Twitter, and then join for example, some Elon Musk's Discord, something like that. And if you want to verify the on-chain, basically expose all your personal information on-chain. Your Twitter handle, your Discord handle, and when you sign a transaction, your EVM address. So everything on blockchain. So that's only possible with the zero knowledge powered self-sovereign identity services that user collecting all these credentials and generating them from their browser and submit them on-chain without revealing any privacy. And another case was another property I really like about the self-sovereign identity is the data ownership. So let's say one day, if a gamer, you definitely would have a Steam account and you have all your achievements on stored in the Steam's server. Let's say Steam it's out of business one day, all your achievement in your life is gone. Self-sovereign identity allows you to collect them permanently, because it will be just a cryptographic signature that is verifiable anytime. Doesn't matter if Steam is still there or not. And you kind of really own your data. And with Galxe Identity Protocol, the zero knowledge proof powered SSI, then you can generate proof with all these credentials. So that's what I see that was not really possible before, but right now Galxe Identity Protocol enables it.
And right now we're seeing that we're now truly able to transfer that kind of data ownership back to the users. And yeah, also curious to hear if there are any plans to expand Galxe's identity protocol to some other ecosystems, and if so, which kinds of ecosystems would be compatible to using the identity protocol?
Yeah. So right now, identity protocol is deployed on major EVM blockchains, meaning like I remember the mainnet, of course, Gravity, layer 2, the experimenting, the alpha mainnet we have right now, and also Base, BSC, Polygon, Arbitrum, Optimism. We have deployed there, so it's already like the in production use on these chains. But it's not really limited to EVM chains. We can also expand it to other ecosystems like Solana or MoveVM based blockchains like Aptos and Sui, and even some Cosmos blockchains, as long as, because they support Groth 16 proof system. But right now we don't really have a plan, to expanding the identity protocol to so many ecosystems. I think our goal right now is still to serve the EVM communities, to make them to make identity verification on EVM chains possible.
Got it. So right now, just focuses on EVM related chains, but there's a potential to expand it to Solana based, MVM based ecosystems as well.
Yes.
Okay. And just as a last question before we close the session, are there any kinds of announcements that you'd like to make for Galxe, or any kinds of final thoughts that you have for the audience?
Yeah. So for announcement, we will release our parallel EVM 2.0, hopefully next week. Although we already have very good benchmark results for 1.0, then we have a very detailed technical blog and benchmark and source code open source. 2.0 will be much better and more, especially for real world applications and transactions.
Got it. Yeah. So very exciting. Lots of new developments coming up. But yeah, thank you so much, Yumin, for joining us today. Really enjoyed hearing about everything related to Gravity and to the Galxe's identity solution as well. For example, really liked especially the how you mapped out the design considerations when it came about with the architecture for both Gravity, for both the identity protocol, and some of the possibilities that you shed light on for ZK-enabled self-sovereign identities as well. I thought that was all very insightful, and was really happy to have you here today.
Thank you, Alex, for having me. Those are really amazing questions. Well prepared.
Yeah, thank you so much. Appreciate it. And hope to see you next time. Thank you.
Thank you.